talked about the correlation coefficient, which basically tells us if the data is all over the place or not. So looking at this data, I mean, it seems to be fairly linear, and as we look at the data from left to right, it seems to be fairly linear. So I would expect the correlation coefficient of this data to be close to -1, because it goes down to the right, which accounts for the negative, and it's fairly linear, so it's going to be close to -1, where -1 is a perfect line, a perfect decreasing line. In fact, check it out. It tells us the correlation coefficient, and as expected, it's close to -1. So now that we know that this data is pretty linear, how do we come up with the exact line that most perfectly fits this data? The way we come up with it is a bunch of nasty, ugly computations. So let's use StatCrunch to do the computations. Because if we can find the line that best fits the data, it's super helpful. We can make predictions. We can do all sorts of things. But again, the actual math behind it is nasty. So finding that line that best fits the data, we call that the least squares regression line. So least squares regression line. Let's use StatCrunch to calculate that. So I click the little icon and we click open in StatCrunch, and it copies the data over from the problem for you. Now, I'm not going to use the actual homework problem. So instead, let me use the textbook problem that's exactly like it. Again, here I have a list of data. Click on the StatCrunch button. This is problem 5 from section 4.2 of the interactive text. Click on StatCrunch. It copies the data over for you. Alright? So here's the data. Now how am I going to find the line that best fits this data? Well, we click on Stat. And we click on Regression. I'm going to click on Simple Linear to calculate the simple linear regression. So select your x variable. Well, that's going to be my first column, which is fittingly labeled x. So my x variable is going to be my x column. For the y variable, we're going to select the second column, which is so fortunately labeled y. Okay, now all you have to do is click compute, and it spits out the line that best fits your data. So the line, this one specific line that best fits the data, is going to be the line that has -0.71363636 repeating as the slope. So the number in front of x is the slope, and it's going to have 6.55 as the y-intercept. To kind of make all of this concrete, notice that you can click on this little right arrow, and it'll show you a picture of the original data along with the least squares regression line, which is kind of neat. So it shows you the original points plus the line that best fits the data.